Imagine the dense ancient forests of what is now northeastern China. Exactly 50,000 years ago, the landscape is peaceful, populated by the magnificent megafauna of the late Pleistocene epoch, including towering mammoths, giant deer, and heavily armored woolly rhinoceroses. High above this tranquil world, a silent threat is hurtling through the frozen vacuum of space. A hypervelocity extraterrestrial object, a remnant from the very formation of our solar system, is drawn in by Earth's massive gravitational well. It pierces the Pleistocene atmosphere at tens of thousands of kilometers per hour, glowing with intense frictional heat before slamming into the Earth. The sheer kinetic energy of this sudden cosmic collision is estimated at 1 × 10⁻17 joules. To put that abstract physics number into perspective, this explosive yield is equivalent to a magnitude 5.5 earthquake, but instead of rumbling deep underground, all of that devastating energy is focused entirely on the surface. In a fraction of a second, the tranquil forest is completely obliterated. The tremendous heat and pressure instantly vaporize the stony or metallic impactor and flash melt the ancient solid bedrock beneath it, throwing immense plumes of shattered stone, molten glass, and pulverized earth high into the sky. When the thick, choking dust finally settles over the devastated landscape, a massive gaping scar is left in the crust of our planet. Over the next tens of thousands of years, the slow but relentless forces of nature go to work on this cosmic wound. Rain fills the deep depression, forming a pristine and entirely enclosed crater lake. Eventually, the regional climate shifts, the lake drains out, and the resilient forest marches right back across the pulverized terrain. Towering Korean pines, Amur lindens, and Manchurian ash trees take root in the nutrient-rich sediments, completely masking the unimaginable violence of the past under a lush canopy of green. Welcome to another deep dive on G Fun Facts Online, where today we are exploring one of the most spectacular geological marvels on planet Earth. This site is known to the scientific community as the Yilan Crater. Located deep in the Lesser Khingan mountain range of China's Heilongjiang province, this enigmatic crescent-shaped formation was known to local residents for generations simply as Quanshan, which translates to circular mountain ridge. Discovered and confirmed only in the early 2020s, the Chinese forest crater has rapidly become a vital key to understanding our planet's recent history of asteroid impacts. It is shedding light on the mechanics of cosmic collisions, the incredible resilience of terrestrial ecosystems, and the hidden geological secrets of the vast Asian continent. To fully appreciate the monumental significance of the Yilan Crater, we first have to understand the fundamental paradox of impact structures on our home planet. If you look at the Moon, Mars, or Mercury through a basic backyard telescope, you will see barren surfaces absolutely heavily pockmarked by billions of years of continuous asteroid and comet bombardments. Earth, by virtue of its much larger size and immense gravitational pull, has undoubtedly been struck far more often than the Moon. Our planet is simply a bigger target with a stronger magnetic and gravitational attraction. Yet, confirmed impact craters on Earth are exceedingly rare. To date, only around 200 have been definitively identified worldwide. This massive discrepancy is due to Earth's highly dynamic nature. Our planet is essentially a planetary-scale geologic erasure machine. Tectonic plates are constantly shifting, subducting old crust into the fiery mantle and creating new landmasses, physically destroying the evidence of ancient impacts. Massive continental glaciers act like slow-moving bulldozers, shearing the tops off crater rims and grinding the impact rock into fine dust. Relentless wind and water erosion gradually smooth out topographical anomalies over millions of years, while dense vegetation can entirely obscure a massive crater from view. Unless an impact occurred relatively recently in geologic time, or the resulting structure is absolutely massive and located in a geologically stable craton, like the Vredefort Dome in South Africa or the Sudbury Basin in Canada, the physical signatures of the collision are almost always swallowed up by the Earth. China presents a particularly fascinating case study in this planetary game of hide-and-seek. Despite possessing a vast landmass roughly equivalent to that of the United States, a country that boasts dozens of confirmed impact craters, China had a glaring crater deficit for decades. Prior to the year 2020, only a single impact crater had been definitively confirmed in the entire massive country. That was the Yilan Crater in Liaoning province, which is relatively small and dates back to somewhere between 330,000 and 1.1 million years ago. The vast, diverse topography of China, ranging from the shifting sands of the Gobi Desert to the dense, cloud-covered mountains of the south, made spotting the subtle circular depressions of ancient impact sites incredibly difficult for geologists. The discovery of the Yilan Crater shattered this quiet streak, opening a massive floodgate of new impact geology research in East Asia. The unmasking of the Yilan Crater actually began far above the Earth's surface. In high-resolution satellite imagery captured by advanced instruments like the Operational Land Imager on NASA's Landsat 8, a distinct horseshoe-shaped depression stands out clearly against the rolling, heavily forested hills of the Lesser Khingan Range, approximately 20 kilometers northwest of the town of Yilan. When observed from space in the autumn months, the crater's unique topography is spectacularly highlighted by the changing seasons. An iconic Landsat 8 image captured on October 8, 2021, showcased the crater's scalloped northern rim ablaze in vibrant fall foliage. This crescent-shaped ridge rises sharply from the forest floor, reaching staggering heights of up to 150 meters, or about 500 feet, above the interior basin. Spanning 1.85 kilometers, or roughly 1.15 miles. At its widest point, Yilan immediately captured the undivided attention of geological researchers worldwide. For a terrestrial crater, its preservation is remarkably pristine, but with one very glaring exception. While the northern, eastern, and western sections of the rim are perfectly preserved and heavily vegetated, the southern third of the crater rim is entirely missing. This missing southern wall initially raised serious questions about the structure's true origins. You see, volcanic calderas, glacial cirques, and collapsed karst sinkholes can sometimes mimic the perfect circular shape of impact craters. To prove beyond a shadow of a doubt that Quanshan was forged by a falling star and not just standard terrestrial Earth geology, scientists had to look far beneath the forest floor for the microscopic fingerprints of a cosmic cataclysm. To investigate the true nature of the Yilan structure, a dedicated research team led by scientists from the Guangzhou Institute of Geochemistry and other prominent institutions undertook a massive and highly complex drilling operation. They meticulously positioned their heavy equipment in the exact center of the crater and bored down a staggering 438 meters, or over 1,400 feet, straight into the Earth. What they pulled up from the pitch-black depths was a perfectly preserved timeline of unimaginable destruction and slow geological healing. The uppermost 110 meters of the drill core consisted of thick, dark lacustrine or lake sediments. This was a crucial finding for the team. The presence of deep lakebed deposits proved that the crater must have once been a fully enclosed, bowl-shaped basin capable of holding a massive body of standing water. This implies that the missing southern rim was not absent from the beginning. It must have remained completely intact for thousands of years, allowing the deep lake to form and quietly accumulate organic sediments on its floor, before eventually breaching due to unknown erosional or tectonic forces. But beneath the peaceful lake sediments lay the chaotic evidence of the impact itself. The drill core revealed a massive 319-meter thick unit of brecciated granite. Breccia is a jagged, pulverized mash of unconsolidated rock fragments. The bedrock in this specific region of Heilongjiang consists of Paleozoic to Mesozoic granite complexes, specifically formed during the early Jurassic period, approximately 200 million years ago. When the asteroid struck, it shattered this ancient solid granite deep underground, as if it were a fragile pane of glass. But the absolute holy grail of impact geology was found between the depths of 218 and 237 meters in the brecciated unit. Here, the researchers found true melt products. The intense kinetic energy of the impact had instantly generated temperatures exceeding thousands of degrees Celsius, literally melting the target rock in a fraction of a microsecond. The core samples contain vesicular glass, which is glass filled with tiny holes formed by escaping gas bubbles, as well as teardrop-shaped glass fragments formed as molten rock was violently flung through the air and rapidly cooled mid-flight, alongside recrystallized granite clasts. Furthermore, Detailed petrographic investigations, under incredibly powerful microscopes, revealed the presence of shocked quartz. Quartz is a very common mineral on Earth, but when it is subjected to the incomprehensible and instantaneous pressures of an asteroid impact, its internal crystal lattice is permanently deformed. This deformation manifests as multiple intersecting sets of microscopic lines, known as planar deformation features, or PDFs. The researchers found precise orientations of these PDFs in the quartz grains, a distinct and undeniable signature that can only be produced by shock metamorphism from a hypervelocity impact. As a final, irrefutable piece of evidence, they discovered crystallite aggregates of coesite. Coesite is a rare, ultra-high-pressure polymorph of quartz. It typically only forms deep inside the Earth's mantle, where pressures are immense. But here it was found embedded directly within silica glass, created instantly by the cosmic strike. The scientific verdict was unanimous and entirely unambiguous. The Chinese forest crater was a genuine, high-intensity meteorite impact crater. With its extraterrestrial origin definitively confirmed, the next crucial step for the scientific team was determining the exact age of the crater. Researchers carefully extracted samples of organic charcoal and lakebed sediments from the drill core and subjected them to radiocarbon, or carbon-14, dating. The results were astonishing. The impact event occurred a mere 46,100 to 53,000 years ago, placing it firmly in the late Pleistocene epoch. This relatively young age makes the Yilan Crater an absolute titan in the world of impact geology. Spanning nearly 2 kilometers across, Yilan is officially the largest impact crater on planet Earth, under 100,000 years old. To put this immense scale in perspective, Yilan's closest analog is the world-famous Meteor Crater, also known as Barringer Crater, located in the Painted Deserts of Arizona in the United States. Meteor Crater also formed roughly 50,000 years ago and is arguably one of the most recognizable impact structures in the entire world. However, Barringer spans only 1.2 kilometers in diameter, making the Chinese forest crater significantly larger and indicative of a much more energetic and devastating collision. Advanced seismic investigations utilizing ultra-dense observation arrays and state-of-the-art smart solo nodes have allowed geophysicists to build highly detailed, three-dimensional velocity models of the crater's subsurface. By employing complex numerical modeling, scientists constrained the exact parameters of the impact. Whether the object was a highly dense iron meteorite or a larger porous stony asteroid, the residual kinetic energy upon striking the Earth was roughly 1 × 10⁻¹7 joules. The shock wave radiating through the Lesser Khingan Mountains would have leveled ancient forests for miles around and ignited widespread catastrophic wildfires. The remnants of those exact fires were likely the very charcoal layers the scientists dated in the drill core. As we mentioned earlier, at the time of the impact, the regional environment was drastically different. The late Pleistocene was the era of megafauna. The sudden, violent release of energy from the Yilan impact likely had a considerable, albeit localized, effect on these massive prehistoric mammals, devastating the regional flora and fauna in a blinding flash of light and a deafening supersonic boom that would have echoed across the Asian continent. While the origin and age of the crater have been solved, the Yilan structure still harbors deep geological mysteries. Chief among them is the ultimate fate of its southern rim. As noted by researchers, the topography features a stark contrast between the towering 150-meter-high northern crescent and the completely flattened southern boundary. The discovery of the thick 110-meter lacustrine sediment layer proves the crater harbored a deep closed basin lake for a significant period. So how did a mountain-sized wall of solid granite simply vanish into thin air? Scientists are continuing to investigate this incredible anomaly. One prominent theory involves the gradual accumulation of water over thousands of years. As the regional climate fluctuated, heavy precipitation and regional drainage may have simply overfilled the crater lake. The immense hydrostatic pressure of millions of gallons of water pressing constantly against the fractured, brecciated rock of the southern rim could have eventually caused a catastrophic structural failure. This would have led to a massive, violent blowout and the rapid draining of the lake. Alternatively, glacial activity during the last glacial maximum could have violently scoured the southern rim away. Or, deep tectonic shifts could have caused the fractured rock to slump and rapidly erode. Regardless of the exact mechanism, the missing rim provides a totally unique window into the post-impact evolution of crater environments, showcasing exactly how Earth's surface aggressively reclaims and reshapes its cosmic scars over time. The confirmation of the Yilan Crater acted as a powerful catalyst, sparking a literal crater rush among geologists in China. Armed with new satellite imaging techniques, advanced subsurface seismic mapping technologies, and a much deeper understanding of localized shock metamorphism, scientists began identifying new impact structures across the country at an absolutely unprecedented rate. Shortly after Yilan's confirmation, an incredible discovery was made in the neighboring Jilin province. This was the Baizhifeng Crater. Unlike Yilan, which sits in a forested valley, the Baizhifeng Crater is a mountaintop anomaly. It is the world's first confirmed alpine impact crater, situated entirely on the summit of Baizhifeng Mountain at a staggering elevation of over 1,300 meters. Spanning 1,400 meters in diameter, the crater is shaped like a giant ice bucket or funnel, sitting precariously between two peaks. For generations, local residents marveled at what they called the heavenly stones, which were massive fields of gray-white sandstone and Jurassic granite fragments that cascaded down the steep mountain slopes like stone waterfalls. It was a complete mystery until researchers found those telling planar deformation features in the quartz samples, confirming that an asteroid collision had literally blown the top off the mountain tens of thousands of years ago, permanently shaping the modern peaks of pre-Baiji and post-Baiji. The discoveries did not stop in the north, either. Deep in the tropical, mountainous terrain of southern China's Guangdong province, researchers identified the Yilan Crater near the city of Zhaoqing. Measuring about 900 meters in diameter, the Yilan Crater is the first confirmed impact structure in southern China, a vast region that accounts for a quarter of the entire nation's landmass. Fascinatingly, the Yilan impact is exceptionally young. It occurred around 10,000 years ago, right during the dawn of early human civilization. Caused by a 30-meter-wide extraterrestrial object, the impact released energy estimated at 600,000 tons of TNT. That is equivalent to the explosive power of 40 Hiroshima-sized atomic bombs detonating at once. Together with the older Yilan Crater and the newly identified Yilan Crater, China's verified impact structures have grown to 5, painting a vivid picture of a landscape routinely battered by the cosmos. But perhaps the most poetic aspect of the Yilan Crater is its modern role as a sanctuary for biodiversity. The violent energy that excavated Quanshan is long gone, replaced by the quiet, persistent forces of life. The Lesser Qing'an mountain range is one of northern China's most critical natural forest barriers, separating the Amur River Valley from the Nenjiang River Valley. The crater and its surrounding topography are heavily forested, dominated by ancient, towering Korean pines, also known as red pines. These magnificent trees, often referred to as the kings of the forest, are an endemic species to Northeast Asia and play a vital role in carbon sequestration and climate regulation. Within this lush, 97% forest-covered ecosystem, life absolutely thrives in the very depression carved by an asteroid. The deep soils formed from the ancient lakebed sediments inside the Yilan Crater provide rich, unparalleled nutrients for over 600 plant species, including Amur linden, Manchurian ash, and wild soybean. This dense taiga environment is a critical habitat for some of Asia's most majestic and endangered wildlife. Extensive conservation efforts and a strict ban on commercial logging in the Qingan Mountains have allowed nature to fully reclaim the region. Today, the pristine forests surrounding the Yilan Crater are home to the Eurasian lynx, elusive wolverines, sable, Siberian musk deer, and red deer. Most remarkably, the region serves as a rapidly expanding territory for the critically endangered Siberian tiger, acting as a protected ecological corridor where these massive apex predators can roam through the ancient blast zone completely undisturbed. The Chinese forest crater is far more than just a geological anomaly. It is a profound monument to the dynamic and often violent relationship between Earth and the wider universe. Hidden for millennia beneath a canopy of towering pines, the Yilan Crater serves as a stark reminder of the immense, sudden destruction that space can inflict upon our world. Yet, as visitors stand on the crescent-shaped ridge of Quanshan and look out over the vibrant autumn foliage, the overriding feeling is not one of destruction, but of profound resilience. The 438-meter drill core pulled from the crater's heart tells a complete and beautiful story, moving from ancient Jurassic granite to the blinding flash of a hypervelocity impact 50,000 years ago, to the slow, quiet accumulation of a deep crater lake, and finally, to the thriving, vibrant forest ecosystem that exists today. As scientists continue to study Yilan, Baizhifeng, and the other newly discovered impact structures across China, they are doing much more than just cataloging the scars of the past. They are calculating the residual kinetic energies, modeling the planetary defenses of the future, and unearthing the long-hidden secrets of how our living, breathing planet responds to the touch of the cosmos. In the heart of the Lesser Khingan Mountains, the universe left a fiery footprint, and the Earth, in its infinite patience, grew a forest over it. Thank you for joining us on this incredible journey here on G Fun Facts Online. We hope you enjoyed exploring the cosmos and our beautiful planet with us. Stay curious, and we will see you in the next deep dive.